So number 12 is our big question. We want to actually solve 3 equations using elementary operations. So our objective here is to use elimination, maybe double elimination if the case may be, to actually solve for x, y, and z. We're assuming that because they're asking us to solve it, these can actually be solved. Okay, and so let's pick 2 equations at a time and work with them to solve. So what can we do? Where should we start this? Let's look at, we could pick equation number 1. What do I notice about equation number 1? Well, it's got 3 variables. The other 2 only have 2 each. So maybe they might be easier to work with to actually solve something. So let's take equation 2. Equation 2, I could write that as x equals 1 plus y. So I have an expression for x in terms of y. If I do the same thing for equation 3, I'll put the z on the right-hand side. I have an expression for z in terms of y. Now, why is that helpful? Now, if we go back to question 1, or equation 1, which was x plus y plus z equals 0, I can replace the x with 1 plus y. I can keep y the way it is. And I can replace the z with y plus 5. So all of my equations are now written in terms of y. I've only got one variable to deal with. I end up with 3y's plus 6 equals 0, or 3y is negative 6. So y is negative 2. Once I got y, well, I can go back and get x. X is 1 plus y, which is 1 plus negative 2. So in other words, negative 1. And z, same thing. It's y plus 5. So negative 2 plus 5 gives us 3. Our POI is negative 1, negative 2, and sorry, it's so hard to read there, 3. Okay, that's actually a pretty nice one. And we can usually do that if you end up with only 2 variables in each equation. Okay, let's look at the trickier one. Letter B. So, got ourselves 3 equations again. I see 3 variables in all 3 of them. There's no real shortcuts this time. So I need to pick 2 at a time and work with them. Doesn't matter which ones you work with. I'm just going to pick the first 2 just to start it off. I want to do elimination with those 2 things. So I'm going to get the x's the same. So I got 2x minus 3y plus z equals 6. And if I times this one by 2, I'll get 2x plus 2y plus 4z equals, and we've got a big number here, 62. Okay, x's are the same. We're going to subtract. So we get negative 5y. Z minus 4 would be negative 3z. And 6 minus 62, that's negative 56. Okay, so I'm going down to 2 variables. But can't solve 2 variables, 1 equation. So I need to pick 2 other equations. Let's take equations 2 and 3 this time. So equations 2 and 3 are x plus y plus 2z equals 31, and x minus 2y minus z equals negative 17. I want to eliminate the x's again. Now it's my objective here, right? Eliminate the same letter from both equations. So I'm going to subtract. Y minus negative 2y will give us 3y's. And 2 minus negative 1 gives us 3z's. And 37 minus negative 17 gives us 48. So I've got 2 equations again, and they can be double eliminated. Now, kind of nice this time, my z's are already the same number. They're both 3's. They have opposite signs, however, which means I'm going to have to add. So I'll end up with negative 2y's, no z's, and negative 8. So y is 4. And now that I got y is 4, I go back to one of my two original equations. That would be this one or this one. Let's use the positive one. 3y plus 3z is 48. What's y though? Y is 4. That's 48. Oops, a little too high there. So 3z equals 48 minus 12. I had to get an x there. Sorry guys, should be a z. Already silly mistake there. Okay, 3z. 48 minus 12 is 36. So z is 12. I got my y, got my z. Oh, I still need x. So go back to one of my original equations that's way back at the top here. So I'll pick one of these three. I'm going to use the middle one. X plus y plus 2z. X plus y plus 2z equals 31. What do I know? I know that y is 4. I know that z is 12. So I get x plus 28 equals 31. In other words, x is 3. So our POI between these lines is 3, 4, and 12. There's our solution. Okay, that's number 5. I mean, that would be letter B, sorry. Okay, let's look at C, last one. Oh, where's C? B, oh, put the number on, 12C. Okay, so solve this using our same old things. Now, good news, Hades only have 2 letters each, right? So maybe we can use that shortcut idea we started with. So let's take the first equation and get one of the letters by itself. I'm going to get x by itself. So x equals 10 minus y. If there's something else I can get by itself, maybe the second one, I can get z by itself. Z would be negative 2 plus y. What can I do now? Can I solve something? Well, if I look at the third equation, I can plug in, if I put this in here, I got a y and a z. If I put this in here, I got a y and an x. That didn't really help me so much there, right? So I don't know if I can necessarily use a shortcut in this one. It looked like I could because I only had 2 equations each, or 2 variables in each equation, but I don't know if I can use a shortcut. So let's, I'm going to have to use 2 variables at a time. Let's do this one. Let's take this and put it in here, okay? So we end up with negative 2 plus y plus z equals negative 4. Or in other words, y plus z equals, this over here, negative 2. Hey, you know what? That's not too bad, right? Sorry, I got distracted. We gotta start over again here. Sorry, my fault. I put it in for the wrong letter. 2. Okay, so starting all over again. You know what? Let's start the whole thing over again. Let's get rid of this. So there's no shortcuts in this one because none of these letters match up. Notice that already. So I'm gonna have to make 2 equations and do my elimination. So if I can get one equation in terms of x plus y equals a number, and the other equation x plus y equals a number, it'll make my life easier. So let's get rid of the z in this one. So z equals negative 2 minus y, and I can plug that into the next one. So I end up with x plus z, but z is negative 2 minus y equals negative 4. So in other words, I have x minus 2 minus y equals negative 4. Or x minus y equals, bring the 2 to this side, I'll get negative 2. If I combine that with the very first equation, bring this over here, I'll have x plus y equals 10. I can do my elimination. My x's are the same, so I'm going to subtract. I'll get negative 2y equals negative 12, which means y is 6. Let's go back to one of my original equations. X plus y was 10, but y was 6. So x must be 4. And I also knew that x plus z equals negative 4, where, well, I just figured what x was. It was 4 plus z is negative 4. So now I get z equals negative 8. So our POI is 4. That's a crazy looking line there. 4, 6, and negative 8. And there's your POI.